go. Double check, make sure we're still recording from the right channel. Okay, so everything's good. And then we start at the browser. All right. There will be a part of this lecture that I can, that I'm going to use a whiteboard for. So you might want to take a picture or just write down the notes, when I do that. And I thought I started a browser.
I think that's the third time you started the browser.
And it's not starting up.
I squeeze it.
Okay. Well, Ice Whistle can start, but not Google Chrome, which is really odd. Oh, wrong Doodle. There we go. All right. So what we'll do today is to talk about arrays. And the first thing I'll do is to explain why arrays are important, because that's usually the way I do things is to first explain why a concept is important. What are we missing without that concept? So that's the first thing we'll do today. Let's go ahead and start with an algorithm that we already know already. Okay, it's something that we have seen many times. And let me change the font size. Let's make it a little bigger, like that. Okay. All right, so here's an algorithm that we have seen many times. We have proved the correctness of this one. It looks like this. If x is greater than y, then z gets x, else z gets y, and if. And we have seen this algorithm many times. What does it do? It finds the maximum of the two variables x and y, and turns z into the maximum of those two. So we have seen this one before. We have proved the correctness. That's no big deal. Okay, and then we also looked at this algorithm at least once, which is finding the maximum of three variables in this case. So if w is greater than or equal to x and w is greater than or equal to y, that makes w the largest of the three. Okay, there may be one that ties with it, or they all tie with w, but w for sure is the maximum in this case. So z gets w. Okay, and then we can do about the same thing here and say, what if x is greater than or equal to w, and x is greater than or equal to y? Then we can say, oh, okay, in that case, x is the maximum. If w and x are not the maximum, since we only have three variables to consider in this case, y must be the maximum, and so we can say, okay, y is the maximum, and we'll make z the same as y in that case. So we have seen this algorithm. If I tell you I want to find the maximum of 4 variables, do you guys think that you can do it? Just following the pattern of the one that finds the maximum of 3 variables. I mean, sure. I mean, it's just, if v is greater than or equal to w, x, and y, then v is the maximum, and we'll have an assignment to say, z gets the value of v. Else, if w is greater than or equal to v, x, and y, then we'll confirm that w is the maximum, and so on. So you can use this approach and say, well, we can handle just about any number of variables, no problem. What if we have 30 variables? It gets a little lengthy, doesn't it? Okay, we're running out of letters, single letters. We have to use like double letters or something else so that we can name the variables. What about 30,000 variables? That won't be fun, right? What if I tell you to write an algorithm to find the maximum of 30,000 variables? And then a day later, I come back and say, you know what? I just changed my mind. I need to find the maximum of 30,001 variables. To you, is that a little change? No. Because you have to change every condition to watch out for that one extra variable. Now there are ways to shortcut it, but nonetheless it is still kind of painstaking just to add one more variable to the mix. What if I tell you this? If I use this algorithm, it can find the maximum given any number of values. Okay, so I'll give you the algorithm first. Don't worry about the syntax, because there will be something that we haven't seen before, but don't let that bother you for the time being. So in this case, we have m gets a bracket 0, while I is less than bar a bar. Do the following. If m is less than a bracket I, m gets a bracket I. And if I gets I plus 1 and while. Okay, so don't mind the syntax of this particular code, pseudocode here. But what if I tell you this code can find the maximum of one variable? That's trivial, right? It can find the maximum of 2, 4, 30,000, 3 million. It doesn't change the code itself. Now, how much time it takes to execute? Yes, that will get changed. However, the pseudocode itself can handle just about any number of values if you just want to find the maximum of those values. So would that be a good solution? Okay, this is why we need arrays in programming. It gives us the ability to do something like that. Okay. All right. So now that we have introduced the reason why we want to use arrays in programming, it's time to introduce some nomenclature and also some concepts. I think last time we started on this one already. We started to talk about how an array is like a box, right? You guys still remember? So I'm going to repeat that because it's over the weekend and most people probably cannot remember what we talked about before. Okay, so I'll draw 3 coffee mugs here. And this is the old way or the current way of doing things. Each coffee mug has a unique name, okay, so that we can refer to variable x, variable y, and variable z. Okay, and the name allows us to point to a particular coffee mug and say, I want to refer to this one, or I want to refer to the other one. Okay, so now we introduce the concept of a box. So here's a box. And we can put things inside the box now. So in this case, I can put 3 coffee mugs inside the same box, like that. The box itself needs a name because I need to identify and say which box are we talking about. I'm naming this box A, okay? It can be any name. And as long as this name does not conflict with all the other coffee mugs or boxes, it's okay. But the trick of naming the coffee mugs inside the box is why arrays are so useful. It's because inside the coffee mug, inside the box, the coffee mugs are not named, they are numbered. And they are always starting from 0. So this is coffee mug number 0, number 1, and number 2 inside the box A. Okay, so it seems like, well, so what is the big deal? Okay, if I want to designate a particular coffee mug, let's say this one here, then I can say, hey, I want to refer to box A and coffee mug number 1. So I have to name the box first, and then I say which coffee mug by its number inside the box, then I can designate a particular coffee mug. Are we still doing okay so far? So instead of having a single name, it sounds like we are just adding more complexity but not gaining anything in return. Okay, any questions? No questions? Okay, so this is the way I write it out, in a human understandable language. But most programming languages will basically use this particular format to refer to box A, and use the square bracket in this case to enclose the number of the coffee mug inside the box. The syntax, coincidentally, is also kind of resembling a box, because if you look at the square bracket, it kind of looks like a box, right? And the name of the box, which is A, is outside of the box, just like you have to put the name of the box outside the box, because otherwise it doesn't, it's not helpful. The number referring to the item or the coffee mug inside the box is within the square brackets. Is that okay? I mean, does everybody understand the syntax of referring to a particular coffee mug inside a box? Okay, so that's the first syntax here. The second syntax, if you look at the algorithm, is the bar A bar notation. The bar A bar notation is kind of like this. We're trying to find out how big is the box, or more precisely, how many items are in the box. In this particular case, what do you think is bar A bar? It counts the number of coffee mugs inside the box. So there'll be 3 in this case. Okay, so bar A bar in this case is 3 because we are counting there are exactly 3 items inside the box. And that's it. Okay, so the concept of an array is really just introducing what we call an indexing operator here. The square bracket is called indexing because you are basically referring to a particular item inside the box. And the other operator is bar A bar, which is finding out the number of items in a box. Those are the only 2 additional syntax when it comes to using arrays. So it doesn't seem like it's impacting pseudocode all that much. I mean, we are just introducing a way to find a particular item in a box and a way to find out how many items are in a box. But trust me, it does fundamentally change the way we write programs. Okay? The reason why it's fundamentally changing the way we write programs has to do with what can you put inside the square brackets. That is the question. Because I can use a constant like a bracket 1, which is a constant, which is always referring to coffee mug number 1 inside the box A. On the other hand, I can also use something that looks like this. I can say I plus j, the whole thing divided by 2 plus z, and multiply that by 3, and so on and so forth. In other words, I can use an expression instead of a constant between the square brackets. What do you think that's buying me? I can now use an expression to help me find out which item I want to look at inside a box. It is no longer a constant. It is something that can change. Because if you look at this expression here, which is kind of artificially complicated, I can change I or j or z, and it will change the overall value of the expression. That means if this is stuck in a loop and I'm changing I, j, or z, the very same statement can refer to different elements at different iterations of the loop. Okay. Is that concept okay?
So you can use the notation for either like an index for an item number or an actual function to help you search.
To help you figure out what you want to access. Okay. All right. So the first thing I want to do is to open up the notes, because as some of you said, you could not read the notes. It's a universal problem with most of the links. I think it has to do with when I transition Moodle to a new version, somehow it just introduced the incompatibility in the process. So what I'll do is I'm going to change that first so that you guys can actually read the notes. And it's right here. And I'll go ahead and just change the settings. It has to do with appearance, and I'll change it to automatic. That will fix the problem. But I'm not going to read from the notes. Okay, so this is just so that you guys can read the notes from Moodle. Okay, so what we'll do is I'm going to write an algorithm to make use of an array. So we'll basically do a few of those examples today. And every time we do something like that, I'm going to use a spreadsheet. The spreadsheet idea is not really just so that we have a table format for tracing, but this also kind of illustrates how the data is stored in computer memory. Okay, so we'll go ahead and just look at the first one first. This one is okay. I'm gonna pick a slightly different example from the one I used in the morning. So we go to tools, autocorrect options, because I couldn't get to the persistent drive before this. So I'm going to have to use the replacement table, but turn off everything else. Zoom a little bit. All right, so still doing the capitalization because it's inside the replacement table. Oops, not this one. Autocorrect options, and if I look at the table, there's one entry for I all by itself. Let's see. Right there. Get rid of it. Okay, so now we can say I gets, well, we'll say I gets 0. And then we say while I is less than bar a bar, you will probably see this kind of outline, in many, many different examples, because that's how we go through all the items in an array. And what I'll do is I'm going to say a bracket I gets, I don't know, 14 minus I. Okay, I gets I plus 1, and while. Okay, so we'll basically stare at this algorithm for just a little bit to recognize things that we do understand, and then we point out the things that are kind of new and maybe we don't quite understand what it's doing in this algorithm. Yep, go ahead.
For this to work though, wouldn't you have to define a length or a
Yes.
number of, okay. that's
Yep.
just-
So when we do the trace, I have to kind of let you know how big the array is. Yep. Okay. But I just want to identify, is there anything mysterious about line 1? Okay, we have a variable called I, and I initialize that to 0. Okay, no big deal here. Line 2 looks a little bit strange because this is the first time we see the bar a bar notation, which basically say I'm comparing I, which is a normal variable holding a numerical value. I'm just comparing that to the number of items in the array A. Now, I haven't told you the size of the array, so we don't quite know what is bar a bar at this point. We look at statement number 3. That looks kind of funky. Okay, can we really do this? Can we put a bracket I on the left-hand side? Well, yeah. I mean, it is a coffee mug, right? As long as it is a coffee mug, it can store some content. It can go to the left-hand side. Okay. Yep. Yeah. Go ahead.
Last time you said that this was analogous to like a matrix in linear.
Like a vector.
Like a vector.
It's more like a vector because
so like each cup's like I hat, J hat, K hat.
Yeah, it's more like a x0. If you look at if it's a vector, then it's one-dimensional. And in this class, we only talk about one-dimensional array, so it's more it's resembling a vector more than a matrix in general.
Okay.
Yep. Go ahead.
Just for the sake of simplicity, why wouldn't that a bar be square bracket?
Because it's not the right notation to use. Because I want to refer to the size of the array and not accessing a particular element in the array.
So couldn't you pass that without passing in an element in the array? Put in the A?
But that's not what the algorithm is intending to do. The algorithm wants to go through all the elements in the array.
Right, so if you just left it blank, wouldn't you do that same thing?
If I leave what blank?
If you left the open close brackets blank next to the bar a bar. In other words, why would you do bar a bar and then in the bottom you do a bracket?
Because there are two different types of operators. One finds the number of elements in an array. The other one says, okay, you want to access a particular element in the array. Tell me which one you want to access, and I'll give you that particular coffee mug. One is counting the number of coffee mugs in a box. The other one allows you to access a particular coffee mug in a box.
So syntactically, for what we're doing here, that wouldn't make sense to do that in the
That would not be the intention of my algorithm.
Okay.
Yep. Okay. So statement number 3 looks kind of funny because there are things that we do recognize and then there are things that we don't quite recognize. We'll kind of talk about it when we trace the algorithm. Line 4, does that look familiar to you? Yeah, we have done that many, many times. Okay. So before we move on any further, I can already point out that these lines here, the highlighted lines here, you will find this to be a fairly common structure for many algorithms that we use in arrays. Okay, we initialize, a value to start from the beginning of an array. We say we stay in the loop as long as we have not reached the end of the array. At the end of the loop, we say move on to the next item. And then line 3 is the only line that is going to change, okay? Because what are we doing to each element in the array? Well, that kind of depends on what the algorithm is intending to do. So that's the only part that is going to change significantly. But lines 1, 2, 4, and 5, it's kind of like a common structure to many algorithms that we'll use with arrays. Okay. Now we'll move on and basically trace the algorithm. And we'll find out how we represent an array in this case, because that really is a question, is how do we represent an array in terms of the columns? Because in this particular picture, we have variable x, which has its own column. We have variable y, which has its own column, and variable z, which has its own column. Because anything that can contain a value independently to everything else needs its own column, because its value is independent to all of the other variables. It's the same way with arrays. Okay? If you look at this picture here with the 3 coffee mugs inside the box, the content of these 3 coffee mugs is independent to each other. Okay? There's no relationship whatsoever that coffee mug 1 has to be 1/2 of coffee mug 0 or anything like that. So that's why each coffee mug actually needs its own column in this case. So we'll go ahead and take a look at how we allocate the columns in this case. We have comments because we do have a condition on line 2. We got line number, we have I as a usual variable, nothing special about it. And then we have array A. Array A in this case, I'm going to say, okay, let's go ahead and allocate 3 elements for this, array here. So we have A bracket 0, A bracket 1, and A bracket 2. Each element in the array has its own column. So its value is different or is independent to all of the other values.
Where did you declare that at?
I declare it right here. So when I trace it, I will tell you how long the array is.
So it's like, in other words, it's like, shouldn't that have been declared like around
No, it's a precondition. This is basically a precondition that I provide so you can trace the rest of it.
Okay.
Yep. So I and all the elements in array A would start with some unknown value. I'm just telling you the array has 3 elements. Okay. All right. Are there any questions about the trace at this point? So I'm telling you ahead of time that the box has 3 coffee mugs.
In terms of data types, is that something appropriate for us to get into in this class, or no?
We're not going to get into data types just yet, okay? So that we can just focus on the concept of indexing and the size of something. Okay. All right. So we start execution on line 1. Line 1 says, okay, I gets a value of 0. That's easy enough. And then we get to line 2. Line 2 is already a little bit, it's using a new concept already. Okay, I has a value of 0, so we know how to deal with I. What is bar A bar? The number of elements in the array. In this case, it is 3. Okay, so 0 is less than 3 is true. Okay, well, that's not too bad. Let's look at line 3. Line 3 looks kind of funky because we have never seen or done anything like this before. So let's go ahead and kind of refresh our memory of what an assignment statement is. An assignment statement has 2 sides, right? It has a left-hand side and it has a right-hand side. What does the right-hand side do? The right-hand side provides a value. Okay, that's all it's going to do, is provide a value. What is the left-hand side doing? Why do we need a left-hand side in an assignment statement? It specifies where to store the value, right? The right-hand side provides a value, and then the left-hand side says, okay, where are we storing it? That's basically what the 2 sides are doing. The right-hand side in this case is pretty simple. 14 minus I, so we just have to say, okay, I is 0, 14 minus 0 is 14. That's the right-hand side. It is a value. It's just 14. What are we doing with 14 in this case? Well, we are storing it to the left-hand side. The left-hand side is A bracket I. Well, what is I? What is the value of I? 0. So A bracket I is referring to A bracket 0. So which column do you think I should be updating?
D.
Column D, exactly. So now we say column D gets a value of 14 because it's 14 minus 0. Then we move on to line 4. Remember, I is a ordinary, nothing special kind of variable. We are just adding 1 to it. Goes from 0 to 1. Then we go back to line 2. I is now 1. 1 is less than bar A bar, which is 3, is true. We go to line 3 again. And this time, we have to reevaluate the right-hand side and the left-hand side because line 3 depends on I. Okay, depending on the value of I, both the right-hand side and the left-hand side would change. In this case, what is the right-hand side? 14 minus I is 14 minus 1, which is 13. What about the left-hand side? I is not 0 this time. I is 1 this time. So the left-hand side is no longer referring to A bracket 0 in the first iteration. It's now referring to A bracket 1, which is column E. So that's why we store a value of 13 into column E. Is that okay? No?
With the array, all of those placings are just memory locations without values. So in the I is an assignment of a 0 value. So for that variable, so you can't put 0 and compare it against the memory location that doesn't even have.
I'm not comparing anything.
Well, you just said is the A bracket I, and A bracket I is just saying that what you're saying is that it's going against the D, and
because I had a value of 0 when I
is,
executed line 3 on row 6 of the trace.
right, but the 0 is the assignment of the variable, not which doesn't make
0 is a value.
right.
It's
but
not
memory
a
location, and the 0 and the A is just
But,
memory location.
but that's exactly the whole point of the square bracket operator. You specify the box on the outside, you specify an integer that refers to the number of the mug in the inside, and therefore you can designate or specify a particular coffee mug inside the box. So in this case, I have I to give me the value of the number of the mug that I want to access. So when I had a value of 0, I say, oh, okay, I want to refer to the first coffee mug numbered 0 in the box. When I had has a value of 1 at this point, I'm saying, oh, okay, this coffee mug has a number of 1, and therefore I'm accessing it, at this point.
So the mug is the memory location in that.
Let's not worry about memory location. Let's just use coffee mugs.
I'm just, it's already hardwired in me, so I'm just trying to understand this in a way that, it's okay.
Array indexing is just saying, give me a number, I will get you the coffee mug. Okay? It's a bartender. It's a bartender, tell me what the box is, and then give me a number, I'll get you the right coffee mug. Okay? That's all it's going to do.
Roll sheet.
Row sheet. Very good. Thank you for the reminder. There we go. Okay. So after this, it's not going to be very exciting because we're just adding 1 to I. We go back to line 2. I now has a value of 2. 2 is less than 3 is true for the last time. And then we go to line 3. Okay, so once again on line 3, what are we doing? Well, on line 3, we are once again evaluating the right-hand side so that we can have a value. And then we have to find out where we are storing it by looking at the left-hand side. So we have to start with the right-hand side again. 14 minus I. I now has a value of 2, so it becomes 14 minus 2, which is 12. Good. The right-hand side is 12. The left-hand side is A bracket I, but I has a value of 2 at this point. So that means it is telling me to go to box A and give me the coffee mug with a number 2 on it. So that would be the third item in that particular array. So now where am I going to store 12? Which column? Yep, column F. So now this column has a value of 12. On line 4, we add 1 to I. I goes from 2 to 3. On line 2, we perform the comparison, but this time I is 3, bar A bar is 3, 3 is less than 3 is false. We get out, we get the post, we are done with this trace. What is the significance of this trace? The significance of this trace are these particular rows. Oops, this one here. Okay, so all of these rows in the trace, rows 6, 9, and 12, they are all corresponding to line 3 in the algorithm. But one is corresponding to the first iteration, one is corresponding to the second, and then the third iteration of the loop. And you can see that each time it is storing a value to a different place in the array. And that is why arrays are useful, because now we have a mechanism so that we can say, oh, it's the same line, but if I change whatever is used in the square bracket, if it is an expression with a variable, now I can say, hey, sometimes I can refer to this, other times I can refer to that, and that gives me the flexibility that I need in order to do all kinds of cool stuff. Are we still doing okay so far with this? Yep.
I followed the whole part, but the only question I have is why do you say I is less than the given value? Why not equal to, like, because it looks like when I is equal, like 0.
That is a good question. So let's change the algorithm and mess it up, okay? Well, I mean, it's okay. I mean, it's okay to mess this up because somebody's going to mess this up in cisp300, so you might as well know what's going to happen when a program is messed up like that. Okay, so that's a very good question. I like that. So let's go ahead and save this one first, and then we'll change the algorithm, and then we'll figure out what's going to happen if we make a mistake. All right, so now that we have saved this one, we'll go ahead and save array 2, which has a problem, okay? So in this case, we'll say less than or equal to instead of just less than, okay? And then we'll see what's going to happen. And you know what? I'm going to change the program just a little bit here so that we have an extra variable that we are not going to be using it for just about anything. So we'll have a new variable x, and we'll say variable x has a value of 7. Okay. And this is line 0, so I don't have to change the rest of the line numbers. Okay. So now let's go ahead and redo this whole thing. And where do you think I should store variable x? How about column G? Would that be okay? I mean, I can use any column that is not currently used for my new variable. There's nothing that says column G cannot be used for the new variable G, variable x. So I'm just going to put x here and say, okay, it has an unknown value to start with. And because I have a line 0, I'm going to insert one more row and say on line 0, x gets a value of 7. So, and then change the width of the column a little bit so it all fits on the screen. Okay, so is that okay so far? Nothing really has changed, right? Except for the last iteration. On row 15, I have to do some changes here because all of these are no longer I is less than, they're all becoming I is less than or equal to. Well, that's fine. I mean, if I is less than bar A bar, it has to be less than or equal to bar A bar. So all of these guys are fine because if the original expression is true, the modified expression has to be true as well. This is the only one that I really have to kind of think about it because if the original expression is false, the new expression can be true. In fact, at this point, it is true, right? Okay, well, that's okay. So it is true that we have to get into the loop for one last iteration, right? Is that okay so far? Does everybody understand what I changed in the program and the impact of that change up to this point? Okay, so up to this point, everything is still okay, no problem. And now we go to line 3. Don't you think I have a little bit of a problem here? Because the box only has 3 coffee mugs. They are numbered 0, 1, and 2. And yet, the left-hand side of line 3 is asking for A bracket I, which is A bracket 3, because I now has a value of 3. So what are we going to do? Fire the bartender. Because you're going to the bartender and say, okay, I want you to go to box A and find me the coffee mug with the number 3 on it. But The bartender goes to the box and says, hey, I only have, coffee mug 0, 1, and 2. I don't have what you're asking for. Okay? That's what Visual Basic is going to say. If you write this code in Visual Basic, by the time you get to line 3 on row 16 of the trace, Visual Basic will give you a runtime error and say, oh, on line 3 of this program, we are trying to access an array out of bound, which means we're trying to access an element that does not exist. How many people here are moving on to cisp300 after you pass this class? Very few. How many people are moving on to 360, the C++ class? Okay, so C++ doesn't look at things this way. Not at all. C++ has a different way of looking at things. C++ says, hey, I know where to find element 0, element 1, element 2, so it makes sense that this is element 3. So if this program was written in C and executed in the C environment, what's going to happen is when this line 3 executes, variable x, which has nothing, absolutely nothing to do with the array, is going to be updated to a value of 11. Is that a good thing or a bad thing?
Bad.
It's bad, it's very bad, it's extremely bad. Because now you have a program that is broken, but it doesn't tell you it's broken. Instead, it's having a little bit of a side effect on variables that has nothing to do with the array itself. It's overwriting some location in memory that would have been A bracket 3 if the array had 4 elements. Is that okay?
Why would that be written into it? I mean, why would that not be corrected? Why would it just be built?
Because that's how C does things. Basically, if you look at the perspective of this particular program from a C or C++ compiler's perspective, A is nothing more than a starting point of an array. C actually does not understand where's the end of an array. So when you try to access something out of bound, the indexing operator has no knowledge whatsoever that the array actually only has 3 elements. So when you try to access it out of bound, it would just grab whatever would have been that particular element from the memory of the computer and say, hey, if the array had this element, this will be the location of that element, and I'll just grab it as if it is actually the element in the array. Yep.
So, is memory then linear? As in, could you, in theory, put box A at the very end?
No, memory is contiguous, which means it is just one huge long streams of bytes. There's no boundary whatsoever.
So you can't organize it so that if it does go over, it would go into something that wouldn't affect.
That is correct. Any type of organization is a mirage. Okay, it is it's something that is a make-believe. To the processor, there's no such thing as a boundary. Everything is just contiguous. Okay. Yep. All right. Thank you. Go ahead.
In this case, we have a variable x. What if we didn't have a variable x? What if we didn't declare it?
It would, well, if this program only has variable I and the array A, it would just be overwriting some memory location that doesn't belong to anyone. So there's no actual side effect to this program. But most programs would have some use of memory location after any array. So that means if you try to access or overwrite an array out of its boundary, you would have overwritten something that is actually going to be useful for something. Okay? The big problem is it doesn't show up right here. Okay? The problem doesn't show up right here because you're overwriting the value of variable x. So until such time you need to rely on the value of variable x, nothing, there's no symptom whatsoever. So that's why when you have programs like this, the bug can be all the way up here, but it doesn't show any symptom until you actually have to refer to the value of x, which may be all the way down there. So by the time something happens that you can actually observe, like a program is now misbehaving or is crashing and whatnot, you're so far away from the point of problem, okay, where the problem actually occurred. And this is one of the things that can bite a lot of people who are just starting out programming in C, because a bracket, basically bar A bar, is not an element of the array A. The index of the last element in any array is bar A bar minus 1, because we start counting from 0. Okay? Has anyone started to notice, starting from 0 doesn't seem to make any sense? Because normal people, count from 1, right? 1, 2, 3, 4, we start from 1. So why do you think, with arrays and stuff like that, it would start counting from 0?
Computers count from 0? Do computers count from 0?
The computer does count from 0, but in this case it's counting from 0 because the element 0 is zero element away from the beginning of an array. Element 1 is 1 element away from the beginning of the array. Element 2 is 2 elements away from the beginning of the entire array. That is why it is starting from 0. Are there any questions about this program? Is anyone going to program in Perl, PHP, Python, or one of those scripting languages? Okay? In that case, this program will behave yet differently. Okay? Because what Python or Perl or PHP is going to do is to say something really smart and say, oh, you want to access an array element that does not exist yet. You know what? I can do something to help you. So in that case, so this is the third scenario using a scripting language. Perl or Python or PHP will say, you know what? I can help you with this. I'm going to do this. I will allocate a new column, and now we have element number 3, and then we can go ahead and put an 11 there. Wow, that seems to be pretty smart, and seems to fix the problem, except it creates a new problem now. When am I going to exit the loop? Never, because bar A bar is shifting along with the new element. So now bar A bar is 4, because now we have 4 elements, right? So in the next iteration, it will force the interpretive language to create yet another column, and then bar A bar is incremented again, so it will never exit until you use up all the memory. Until you're so far away, that you have nothing left, and the computer comes back and say, I cannot allocate another column anymore. Then you get a runtime error, and that's usually a pretty hard crash for the program itself. Not the operating system, but for this program, there's no way to recover at that point. All right? So depending on the programming language, VB actually does the right thing. It complains right away and say, hey, there's no such thing as element number 3. I'm going to stop here, tell you the line number, and you have to fix it. That's the right way of doing things. C is really, really subversive. Okay, it's going to change something else without letting you know. And until such time you try to access variable x, you won't notice anything at all. Now the problem with C is sometimes what is trashing, or what is overwriting in this case, is not another variable. It can be something that is even more important to the execution of a program. I'm not going to talk about the actual detail in this class. When you get to cisp300, which is assembly language programming, then you will start to understand, programs like this can lead to even more insidious problems, because if you're just overwriting another variable, it's not the worst. Okay? There are other things that you can overwrite that will create even worse problems. Has anyone heard of stack overflow exploits or buffer overflow exploits? This is what's happening. Okay? With a buffer overflow or stack overflow exploit, there are specifically designed packets, network packets, or files, okay, that are designed to overflow the access of a particular array, and therefore injecting code into memory, content that really should not have actual code. Okay, and then through some really crafty programming, they can make the program continue execution at those overwritten memory locations, and therefore gain access to your system. Okay, There was one time, I'm not sure how many of you actually pay attention to all the patches that your Windows operating system needs. There was one of those, that will allow someone to hack your computer, to gain access to your computer, just by downloading and displaying an image. I'm talking about a very regular type of image. Okay, you go to eBay, you're shopping for, let's say, a watch. Okay, and someone can craft the file in a specific way so that just by looking at the watch, having it displayed in your browser would basically give that person, access to your computer and therefore hack your computer. It's all done by this type of code because somebody at Microsoft did not check the boundary of an array and just say, I'm going to trust the image file that this section would not exceed this many bytes. But what if it does? It's going to overwrite some memory location, and by doing something really crafty, they can continue execution at the overwritten portion. In other words, they can inject code into your computer's memory and execute that arbitrary code as a result, which results in computers getting hacked. All right, so that was a good question. Thank you for mentioning that. All right, but this is also a very good point to basically say, hey, less than and less than or equal to are very different. Okay, just off by one can get you into big trouble. All right, so let's go ahead and look at another algorithm. And this one is a little bit, I will make this a little bit more challenging, but it's really not that challenging. I mean, it's really just a different example. Throughout this class, you will see a lot of examples that I present in the class that looks like this, or even some of the questions in an exam would look like this. It will seem to have something that you have never seen before, but if you apply the concepts that you have already learned and just combine those concepts in the right way, you will still be able to answer the question. So I'm going to give you one example like that. And we're going to do something like this one. Okay, so this one starts with a bracket 0, gets a value of 0. I starts with a value of 1. And then we'll say while I is less than bar a bar, this is starting to get a little bit boring because you can see the condition of the loop is pretty much the same. But what we do in the loop is what is interesting here. Okay, so we'll say a bracket I gets a bracket I minus 1. And I need to figure out the math a little bit here myself too, so let me think about it. Okay, so I'm going to add I minus 1 and add I itself to it. So that makes, nope, this is the one over here. Let me double check whether that's the one. Yep, I think so. I'm just double checking. Okay. No, there's a 2 times here. Okay. Some of you can do the simplification and basically just say, oh, this is just really 2 times I minus 1. It's the same, but I want to retain this format here, just so that I can explain that later on. So we have I against I plus 1, and while. This actually relates to something that we talked about last time about optimization. Some of you may recognize the form, but that's not important. Okay, so now we have a slightly more complicated program where the right-hand side and the left-hand side both refer to some elements in an array. And hey, we haven't seen anything like this before. How are we going to deal with this? Well, the way we're going to deal with this is to use what we already know and see if we can apply what we already know to something that maybe something that we haven't seen exactly before. So we have comments, we have I, and once again we have array A, and once again I'm going to give you 3 elements in this case. So a bracket 0, 1, and 2 are the 3 elements in array A. And we want to figure out what this program is going to do that. Okay, so I have to give you a precondition. The precondition is I do not know anything. Variable I and every element in array A are unknown to begin with. Okay, Are there any questions at this point? Questions? Okay, let's go ahead and start to do something here. On line 1, what are we going to do on line 1? Which column is getting changed? Column D, right? A bracket 0 is column D. The first element in the array is going to get a value of 0. Okay, no big deal. Line 2 is going to be column C because it's a regular, normal variable I. It's getting a value of 1. On line 3, we have the very usual by now, which is I compared to bar A bar, the number of elements. The number of elements in this case is 3. I has a value of 1. 1 is less than 3 is true. Okay, so no big surprises here. Then we move on to the dreaded line 4. What are we going to do about line 4 here? Okay. So now what I'll do is I'm going to do something on the whiteboard. And you might want to copy it if you find it is useful. Or you can just say, well, I know this stuff already. There's no need to copy it. Turn on the last switch. Thank you. All right. So what we'll do is we'll look at line 4. And then we'll break it down in terms of the structure. Okay? So this is the first time we encounter the concept of a tree, except it is growing upside down. The root is pointing up, and all the leaves are pointing down. All right. So the way we do it is we look at line 4, and we ask ourselves, what is the very last operation we are going to perform on line 4? Exactly what is this kind of statement? How do we call this a statement? There's a lot of notifications today. Is it some kind of alert? Because I know a lot of people have Amber Alert on their phone. So if there's something happening, that's, what that can happen. Is there any alert? No? Okay, nothing important? Okay. Well, if there's an active shooting in ARC, I want to know. Because I'm going to ask someone to go outside to lock the door. This is, this kind of lock, definitely was designed, way in the past, okay? Because in order to lock the door, somebody has to be outside to lock the door. And the door opens out instead of in, so it's not really exactly safe by today's standard. All right, so let's look at line 4 here. It's an assignment statement, right? How do we break down an assignment statement? It has a left-hand side and a right-hand side. Okay, fine. Okay, so this is the symbol, of an assignment statement. It has a left-hand side, it has a right-hand side. Okay, very good. The left-hand side specifies where we're storing something, and then the right-hand side specifies the value that we are storing. Is that okay? Okay, we just talked about that, earlier in today's class. Let's focus on the simple side first, okay, on the left-hand side. What is the left-hand side? If you just focus on the left-hand side on line 4, what is the operation that we are trying to do here? How do we call that operation? Square bracket, indexing, okay? It's not exactly dereference, even though the concept does kind of apply to it, but we call it indexing, okay? So we'll just say, okay, this is the indexing operator. It doesn't have the left-hand side and the right-hand side, but it still has 2 pieces of information that it needs, right? Because it needs something to tell me which box are we accessing and what is the number of the coffee mug that we're accessing inside the box. Does that make any sense? It has 2 little pieces of blank that we have to fill in. Okay, so which box are we accessing on line 4 on the left-hand side? Box A. And how do we specify the number of the coffee mug that we are accessing inside the box? It's just I, okay? So we refer to it just as I, okay? Check. We are just rewriting the same thing in a kind of strangely different way, right? Yeah, that's exactly what we are doing. We're actually parsing the expressions here, okay? And I'm going to do some simplification here just so that I don't have to deal with, an overly complicated form. So I'm going to get rid of this -1 here and then just turn that into here. Okay, it's the same thing. I mean, it gives you exactly the same value, except it's a little bit less complicated. Okay, on the right-hand side. So let's focus on just the right-hand side of the assignment statement. What is the last operation that we're going to perform here? You can pick one or the other. You can either do the plus as the last thing you want to do, or do the minus as the last thing you want to do. Okay, it's up to you. Most people or most computers would parse this and basically specify the subtraction as the last thing to do. So we'll do that as the last thing. Subtraction requires two things, right? It has two sides. Let's deal with the easy side first. What is the right-hand side? 1, right? What is the left-hand side? The left-hand side of that subtraction is the sum of a bracket I minus 1 close bracket plus 2 times I, okay? So that is an addition operation. Is that making any sense? I'm basically breaking down the expression in a structural way. Okay, what am I adding here? Adding requires two things. One thing on the left-hand side, one thing on the right-hand side. What is on the left-hand side of the addition? A bracket I plus 1. Okay, so once again, it is an index operator. Okay. An index operator requires two pieces of information. One is the name of the box, in this case it's just A, and also the number that would help me identify which coffee mug I want to access inside the box. In this case, it's not simple because it is I minus 1. So whatever is inside the bracket here is actually a subtraction with I on one side and 1 on the other side. Are we doing okay so far with the breakdown of the structure? Okay. What about the other side of the plus? 2 times I. So that means we're dealing with a multiplication. Multiplication also has two sides. On one side we have a constant of 2. On the other side we have the variable I. And this is how we break down the statement on line 4 to what we call a tree format. Okay, it's also a structure format. And what is the root of this tree? The assignment operation. The very last thing we're going to do is the root of the tree. What are the leaves of this particular tree? The things that cannot be broken down into anything else, okay, cannot be broken down into smaller items. So in this case, it would be the name A, the name I, the name A, the name I, the constant 1, the constant 2, the variable I, and the constant 1. Everything else are called nodes because they are actually somewhere in the tree, they point to somewhere else. Okay. How is this helping me? Well, let's go ahead and trace the algorithm. So I'm going to continue the trace here. Not this one. Find the right one here. Okay, so this is the trace up to this point. We're trying to figure out what line 4 is going to do. Well, let's go ahead and get started. What is I again? If you just look at the trace, what is the current value of I? It's 1. Okay, so I'm going to pick a different color to identify the value of I in this case. So this is 1, and that means we are just actually specifying A bracket 1 on the left-hand side. Is that making any sense? Because I has a value of 1. Okay. Now, because I has a value of 1, I can figure out the rest of the expression as well. Okay, this is 1. 1 minus 1 gives me a 0. So here, this is actually just really specifying A bracket 0. Is that okay? Okay, it's just that we rely on I minus 1 to specify the number of the coffee mug that I want to access inside the box. I is 1, I minus 1 is 0, so we are accessing A bracket 0. Okay, I has a value of 1. 2 times 1 gives me a value of 2. And this is just a 1. All right. So when I need to perform an addition, I need to find out what is the current value of A bracket 0. What is the current value of A bracket 0? It's a value of 0, right? We look up the trace. It is column D. So this really just provides me a value of 0. 0 plus 2 is 2. 2 minus 1 is 1. Oh, okay, we are done. The left-hand side says store something into A bracket 1. Where's A bracket 1 in the trace? Which column?
E.
Column E. So we are storing a value of 1 into column E. Are we doing okay so far with this? Okay, so let's go ahead and update our trace here. On line 4, we update column E with a value of 1. Wow, that's a lot of work just to update one column. On line 5, we add 1 to I. I goes from 1 to 2. We go back to line 3. We ask the question. I is now 2. Bar A bar is still 3. 2 is less than 3 is true. We continue execution onto line 4. Okay, so this time when we get to line 4, things are a little bit different because I is no longer 1. I is now 2. Okay, so what I'm going to do is, I don't have another color, so I'm going to erase what I had a little bit earlier. So if you want to take a picture with a cell phone, this would be a good time. I think people from maybe 20 years ago, taking classes in a college, would never have imagined taking notes can be that simple. You just have to nudge the guy next to you and say, "Wake up, take a picture." All right, are we good to go? Okay, I'm gonna wait a little bit here. And not only can your phone take a picture, the resolution is actually pretty high now. I mean, they started off with what, sub megapixel, so it's really, really awful. And now you have what, 5 megapixel or more? So it really is changing, how we do things. Okay, so I'm gonna erase this now and start, I'm just gonna erase the red value, because the red values are really just for that particular iteration. The structure of the line of line 4 doesn't change. It really is the same tree, except some of the values are now changed because I has changed. All right, so A is still the same, but I now has a value of 2. So A bracket I is actually referring to A bracket 2 in this case, which is column F. Okay, and then we can work on the other side. I has a value of 2. 2 minus 1 gives me a value of 1. And so A bracket I minus 1 close bracket is really just saying, oh, okay, we are referring to A bracket 1. Are we doing okay so far? Okay. I has a value of 2. 2 times 2 has a product of 4. Are we still doing okay? What is the value of A bracket 1? We just store something there, okay, and it is exactly 1. Okay, so that's a value of 1. 1 plus 4 gives me a sum of 5. 5 minus 1 gives me a value of 4. Okay, so now I know exactly what line 4 is going to do. The right-hand side gives me a value of 4. The left-hand side specifies we want to store in A bracket 2. Well, let's do it, because it's just column F. So column F now gets a value of 4. And then on line 5, we add 1 to I. I goes from 2 to 3. We go back to line 3. I is now 3. 3 is less than 3 is false. We are done. We get out of the loop. What do you think, if I change the size of the array to 4 elements, what do you think is going to be in A bracket 3? That's actually not a bad guess, but it's not. It's going to be 9, exactly, because it's just the square of the index. It's the optimization that we talked about last time. You can see sometimes I just recycle material from a previous class. But I want to use this example because I want to show you, how you can break down the structure of a seemingly kind of difficult statement and basically break it down to stuff that we already know how to do and say, oh, okay, so that's how we're going to do it. Are we still doing okay with this one? Okay. Let's try something else. Okay, we have 10 more minutes. It's just enough time to write another example that seems to have something that we haven't seen before, but if you just kind of remember the things that we already understand, it's okay. I mean, we know how to combine, what we know into something that's a little bit new, that we haven't seen before. It's the combination that we haven't seen. It's not really the concept that we haven't seen before. It's kind of like Legos, okay? You have Lego blocks, they're really regular shape, okay, you have 2x2, 2x3, 2x4s, and so on. But how do you combine those blocks to make new things? That really is the question. Okay, so we're going to start with this one here, and I would say found is false in this case. And then we have I at 0. And then we'll say while I is less than bar a bar, do the following. And then we'll say found gets, and I'll use extra parentheses in this case to emphasize what we are doing here. So we'll say a bracket I equals k. I gets I plus 1. In fact, okay, I just made a mistake here. And I really should say found or, okay. While. And that's my pseudocode. Of course, the tricky part is, you know, what am I going to give you in terms of an array? New Windows and start to. Oh, that's a little bit long. Here. Here's the trace, comments, line number, and this time we have I, K, and array A. And once again, we'll just have to go ahead and have 3 elements, bracket 0, bracket 1, bracket 2. And this time I do have to give you, initialized values in the array, because otherwise I cannot compare to something that is not initialized. So I'll just give you like 5, 7, and 2 over here. And K, let's make it 7. And I starts with an unknown value. So that's the code, or that's the condition that I'm giving you. So now we want to figure out what this algorithm is actually trying to do. Oh, I missed one. I missed one variable. I missed found as a variable. Okay, it is a variable. And it starts with an unknown value as well. Okay, that's my precondition. And resize things a little bit. Like that. All right. We start with line 1. And you can look at line 1 and go, we haven't seen anything like this, I'm going to give up. Well, maybe we haven't seen a combination of these things, but we have certainly seen things like this individually in a different context. Overall speaking, line 1 is an assignment statement. What does an assignment statement do? It evaluates the right-hand side, which gives you a value, and then it uses the left-hand side to specify where am I storing the value, right? Okay, that concept doesn't change here. What is the value of the right-hand side? False, right? False is a value, just like 0 is a value, false is a value. Okay, fine. What is the left-hand side? The left-hand side is found, and the only thing that is important about the left-hand side is it has to have a column in a trace so that we can store a value. Does found have a value? I mean a column. Yeah, it has column C. So we're going to store the value false here. That's it. That's how we're going to execute line 1. Okay, we are just storing a Boolean value into a variable. All right? Any questions about this step? Yep.
There's variables, there's strings, and there's booleans, right? That's the whole.
Those are the primary types of most languages. But in this class, we have only focused on numbers and now Booleans. Line 2, we already know what that one's going to do. On line 3, we have I is less than bar a bar. I has a value of 0. Bar a bar is 3. 0 is less than 3 is true. So we move in, we get into the loop here. Okay, I haven't seen anything like this. I'm going to give up. Okay, have we seen comparison? A bracket I. Okay, let's break it down. Okay, this will kind of push my time a little bit, but I can do it at least once. Okay, so at the root here we have an assignment statement. On one side we specify found as a place to store the value. On the other side we have basically a OR operation. That's the last operation on the right-hand side. OR requires 2 things. In this case, the one thing is to refer to the variable found on the left-hand side, and then the other side is an equality check. Okay, equality check requires 2 things to compare. We have, we have an index operation on one side, and then we have k on the other side. The index operation requires 2 pieces of information: the name of the box and also which item in the box I want to access. So that's how we break it down. Okay, now that we break it down, we'll work our way up, okay, using a bottom-up fashion. A bracket I. What is the value of I again? 0. So that means we are trying to access A bracket 0. Okay. And A bracket 0 has a value of what? 5, okay. So this whole side becomes just 5 at the value of 5. What is K? K is a variable that doesn't get changed. It's 7. 5 equals 7 is false. Very good. Okay. So we have false on one side. What is found again? Found is false. Okay, that's how it was initialized. False or false is false. Okay, we're going to store false back into found. Hey, that's not too bad. Go to line 5, we add 1 to I. I goes from 0 to 1. Then we go back to line 3. I is now 1. 1 is less than 3 is still true. Now we have to go back to line 4. And let's see what happens this time. Okay, you guys want to take a picture? Nope. Okay. Next time when I ask that question, I'm going to jump out of your way so I won't be included in the picture. All right. Now, I has a value of 1 now, right? So this is 1. Keep using the one that's kind of faint. So now this becomes A bracket 1. What is the value of A bracket 1? Column G has a value of 7. K is 7. 7 equals 7 is true. Found as a variable has a value of false at this point. False or true is true. We store true into found. All right. Hey, this is not too bad at all, right? And then we move on to line 5. We add 1 to I. I goes from 1 to 2. Now, typically, a loop would have exited by now because I would have found put into the condition itself. So it will say while I is less than bar A bar and not found. But since I did not have that, I'm going to go for one last iteration here. And we are now back to line 4. It's the same exercise. If you think this is getting boring, I am glad. Because if you're not getting bored and say, wow, this is really challenging, then I will start to worry. Okay, because at this point, what is I? Has a value of 2. So now A bracket I refers to A bracket 2. A bracket 2 has a value of 2. K still has a value of 7. We're comparing 2 to 7. It is false. Found has a value of true. True or false is true. So we store true back into found. In fact, once found is true, you cannot turn it into false anymore, because a disjunction cannot turn something into false. It can only turn it into true. So we now move on to line 5. We add 1 to I becomes 3. We go back to line 3. I is now 3. 3 is less than 3. It's false. We get out of the loop. And we say, hey, we just found the value that we're looking for. K, I use the letter K because it stands for key. Okay, we're looking for a particular key in the array, and we just found it. Okay, so what you can do, see, we still have a minute left. So what you can do is to change the array a little bit, just turn the 7 into 8, okay, and keep everything else the same, and see if you can work it out, so that you can make sure that the conclusion, found is still correct, okay, because found is supposed to tell you whether the particular value in K is found in the array or not, okay. So are there any questions before we go home? Yep.
What if there were multiple 7s?
If there are multiple 7s, the encounter of the first one will set found to true, and then the rest wouldn't even matter. Yep. Okay, so I will give you a homework assignment. I'll send you an email when the homework assignment is up on Moodle. Okay. All right. So I'll see you guys on Thursday.